Welcome to this video where we'll be looking at a few issues people have when they are asked to share a given amount into a particular ratio. Here we have an example question. Holly and Simon share the cost of a meal in the ratio 3:4. If Holly paid £42, what was the total cost of the meal? The problem is that some students are taught to follow a strict set of rules for dealing with ratio problems. The worst offender in this situation is Adam. Adam stands for add, divide, and multiply. And students will often blindly follow this method and are unable to sense check their answer. So let's do it and see. So first we are told to add the parts of the ratio together. So the ratio is 3 and 4, so when we do 3 add 4, we get 7. Then we are told to divide our amount, the £42, by that 7. 42 divided by 7 is 6. Students mistakenly believe that everything is going fine right now because they didn't end up with a crazy answer to that division. Finally, we are told to multiply that 6 by each of the parts of the ratio. So 3 multiplied by 6 is 18, and 4 multiplied by 6 is 24. So the total cost of our meal would be the 18 add the 24, which is £42. And yet if you sense check that answer, you can see that it can't possibly be correct. How can the total cost of the meal be the same as what Holly paid on her own? The method didn't work. So we need to find a better way of thinking about these questions. So let's have a look at 4 very similar questions. Okay, Amy and Ben are going to share some money. Every single one of these 4 questions has Amy and Ben doing that. Each of those 4 questions has the ratio 3:1, and each of those 4 questions has an amount of £24. You can see that instead of using a method like Adam, I've drawn blocks for each of these questions to represent the ratio. So the ratio of 3:1 for Amy to Ben means that I've given Amy 3 blocks and I've given Ben 1 block. That's the same in all 4 questions. What changes from question to question is what part of that question the £24 is actually dealing with. So if you look in the first question, Amy and Ben share some money in the ratio 3:1. In this case, the £24 is the total amount of money. So that's all 4 blocks put together is the £24. So how much does Amy get? Well, when we check this, since all 4 blocks is totaling £24, to work out the value of just one of those blocks, you're going to have to do 24 divided by 4 to get 6. That means the value of every one of these blocks is going to be £6. So Ben is going to get just the £6 because he's got 1 block, whereas our answer for this question, Amy, is getting 3 blocks, and each of those blocks is worth £6. So in the first question, Amy is going to receive 18. The second question, Amy and Ben are sharing some money in the ratio 3:1. Same again. But this time, instead of £24 being the total amount, Amy is getting the £24. That is just her money. So 24 is just the 3 blocks of Amy, nothing to do with Ben's. So this time, instead of doing 24 divided by 4, we are only splitting that 24 equally between Amy's 3 blocks. 24 divided by 3 is 8. So this time the blocks are worth 8. The nice thing about these diagrams is that if you know that all of Amy's blocks are worth 8, so is Ben's. The blocks are always worth the same. So answering our question, how much does Ben get? Ben's got 1 block of £8, so Ben is getting just £8. Right, third question. Amy and Ben share some money in the ratio 3:1. So far the same. If Amy gets £24 more than Ben, how much do they have in total? So this time that 24 is a comparison between the two people. Amy's getting £24 more than Ben. Well, if we look at our picture, we can see that Amy does indeed have more blocks. So how much more does she have? Well, Amy's got 3 blocks, Ben has got 1, which means Amy has got 2 blocks more than Ben does. So those 2 blocks is worth £24 that Amy gets more than Ben. So 24 is being divided by 2 to make every block this time being worth 12. So that's worth 12, and so is every block in the question. This time the answer to our question needs to be how much money they have in total. So in total there are 4 blocks and each block is worth 12. So in total they are going to be getting £48. And finally, Amy and Ben have money in the ratio 3:1. If Amy gives Ben £24, they would have the same amount of money. How much do they have in total? So Amy's got 3 blocks, Ben has got 1 block, and Amy's going to give some of her money to Ben, and they're going to end up with the same amount. If you look at this, that would just be that one single block, 1 block on the end, because that 1 block, if it was given to Ben, would make them have 2 blocks each. So that 1 block is going to be the £24. So I don't need to do a division this time, I just know that that 1 block is the £24 that Amy would give to Ben. And as soon as I know what 1 block is worth, every block is worth the exact same amount. So this time, how much do they have in total? Well, we've got 4 blocks, each worth £24, which is a total of 96. So you can see that the Adam method, as discussed earlier, only worked for the very first question. That is the only question where we actually added the 3 and the 1 together to get the 4. All of the others would have failed with that approach. So this is a much more valuable method to be dealing with ratio problems. Now there is one issue, and that is sometimes you may be given a question where there is more than one quantity. In every single one of these questions we are dealing with one ratio and one single amount in 24. That's why we could draw one diagram and have it work. Let's have a look at an example where that's not the case. So Carl is mixing green paint. Blue paint and yellow paint are mixed in the ratio 2:3. Carl has 12 litres of blue paint and 15 litres of yellow paint. What is the maximum amount of green paint that Carl can mix? Now in this situation, because we've got 2 separate quantities, that means we need to answer this question 2 separate times, just dealing with one of those quantities at a time. So this question is actually going to be done twice. Okay, so in the first case, we're going to deal with just the 12 litres of blue paint. So the ratio is 2:3, which is why you can see in both diagrams we've given 2 blocks to blue and 3 blocks to yellow. In the first case, Carl has 12 litres of blue paint. So dealing with just the blue paint, that's just those 2 individual blocks. So the 12 litres of blue, we're going to be doing 12 divided by just those 2 blocks, which means they are each going to be worth 6. So 6 in each of those boxes and 6 in each of the ones below. Now if we look at this question and work out how much paint we have used, the blue paint we can see we have used 12 litres. For the yellow paint, 3 lots of 6 is 18 litres. Now what you should notice now is that that situation is impossible, because we only have 15 litres of yellow paint, which means we couldn't possibly make this with the amount of blue, because we'd need more yellow paint than we actually have. We would need 18, we only have 15. That's where the second part of the question comes in. So this time we're going to disregard the 12 litres of blue paint, and now we're just going to focus on the 15 litres of yellow paint. So once again, we have the ratio of 2 to 3, but this time the amount that is the 15 litres is the yellow paint, so we're just dealing with the yellow paint. So this time we are doing our 15 litres, but we are only dividing that by 3 for the 3 blocks of yellow. 15 divided by 3 is 5, so we have 5 in each of those boxes, and the same for the blue. So in total we are using 10 litres of blue paint, and we're using all 15 litres of yellow. This case can be done because we have 12 litres of blue paint, but we're only going to use 10 litres of it. There will be some blue paint left over, and that's fine. Answering the question, what is the maximum amount of green paint that Carl can mix? Well, since we now know that we are going to be using 10 litres of blue paint and 15 litres of yellow, that means that we're going to have a total of 10 plus 15 litres of paint, which means we're going to end up with 25 litres of green paint, and that will be our answer. Hopefully you've seen through this video that following a strict set of rules such as Adam may not be the best approach to solving a ratio problem. However, using a diagrammatic approach, also known as a bar model, can give you much better results.